gas constant. Okay, whenever you are going to put universal gas constant, you have to put R bar, okay, into N. Okay, that is N is the number of kilomoles, and R bar, actually it is R bar. R bar is universal gas constant. Okay, we know that the total number of the moles in an ideal gas is given by the summation of number of moles for the constituent gases. That is N equals to Na plus Nb plus Nc. So N is total number of kilomoles in the ideal gas mixture. Na is the number of moles for the constituent gas A. Nb is the total number of moles for constituent gas B. Nc is the total number of the moles for constituent gas. Now, so we have to write, okay, remember PV equals to N R bar. You see the notation here, R. It's something is different. This is R bar. R bar is universal gas constant. The value of R bar is 8.314 kilojoules per kg Kelvin. Okay. Now N is Na plus Nb plus Nc. Now you write PV as it is, and on the right hand side we are going to rewrite N R bar T as Na R bar T. This is for the constituent gas E plus Nb into R bar T plus Nc into R bar T. Just whatever the number of kilomoles multiplied by R bar for individual constituent gases. PV equals to Na R bar into T. Assume that the temperature of the ideal gas remains same, plus Nb R bar T plus Nc R bar T, where R bar is universal gas constant. Okay. And so, and we know that R equals to R bar by M. Okay, that is general gas constant equals to universal gas constant divided by molecular weight. Okay, so whenever you are going to express in terms of a general gas constant, you write Na as it is. R bar is nothing but the M into R, capital M. Okay, capital M is nothing but the molecular weight of the constituent gas multiplied by R. You see the difference, this symbol and this symbol. Whatever the symbol it is, universal gas constant. Whenever you are going to express in terms of general gas constant, you have to write product of molecular weight and the general gas constant, because R equals to R bar by M. So R bar equals to R into M. Capital R is general gas constant. Capital M is your the molecular weight. Okay, so we are going to write it as Na capital Ma is the molecular weight into Ra into T. Like that, you have to write for all the individual constituent gases. Okay, Na capital Ma into Ra into T plus Nb capital Mb into Rb into T plus Nc into capital Mc into Rc into T. Okay, so where capital Mr is the product of the molecular weight and general gas constant. It is nothing but a universal gas constant. Okay, like that you have to write, that is the MRT, that is summation of MRT is nothing but you have to write for all the constituent gas. MRT we can write it as Ma into capital Ra into capital C. Don't make confusion between small m and capital M, where small m is mass of the gas in kilogram. Capital M is, it is the molecular mass. Okay, molecular mass is 28 for nitrogen, like that. Small m is mass of the gas, capital M is our molecular weight. Small MRT is Ma into Ra into T plus Mb into Rb into T plus Mc into Rc into T. That is A, B and C indicates the constituent gases in the ideal gas mixture. Okay. So you first you write this one, second this one. Next we are going to divide throughout by empty. So we call it as equation number 2 and this is equation number 1. So dividing throughout by empty. Okay. For equation number 2. R is, okay, because we are going to divide by empty means empty gets cancelled. MARAT is nothing but here MT. MT is MA divided by M into RA. TT gets cancelled. So MA by M into RA plus MB by M into RB plus MC by M into RC. Whenever you are going to divide throughout by MT, you will get R equals to MA by M into RA plus MB by M into RB plus MC by M into RC. Okay, in the previous class, we are discussing with mass fraction. Mass fraction is defined as the ratio of mass of the constituent gas to the total mass of the mixture. Okay, here we are going to represent it as either G or Y. Okay, so in different books they are using different notation. This is YA. YA is the mass fraction for the constituent gas A into RI, put as it is. MB by M is mass fraction of constituent gas B into RB plus YC is nothing but mass fraction of constituent gas C into RC. Okay. Hence, the general gas constant for ideal gas mixture is summation of Yi into Ri, means mass fraction multiplied by uh, the general gas constant for individual gas. Okay, you remember this equation for solving the problem. Okay, so in the previous class I explained on problem. Okay, so there we found out just the general gas constant for the ideal gas mixture is uh, the summation of product of mass fraction and the general gas constant. Okay, so capital R, general gas constant for ideal mixture is Ya into Ra. Ya is the mass fraction Ma by M plus Yb into Rb. Yb is Mb by M. Rb is the general gas constant for the constituent gas 2 plus Yc is Mc divided by M into Rc. So capital R is summation of Yi into Ri. Okay. So remember this equation. Sometimes they may ask to derive this one. Very simple equation. You have to find out like this. And today I'll discuss one more important concept. Okay, called as internal energy is a function of temperature only. Okay. We discussed in first law of thermodynamics. Okay, I am telling this chapter is mainly related to your module 2. Whatever you studied, same thing you are studying here also. Okay. Meantime, we are having one derivation. So every time they used to ask, prove that the internal energy is function of temperature. Only one of the important derivation. They may ask for 8 marks. This is the 8 marks question. Okay, to prove that internal energy is a function of temperature only. So internal energy always depends upon the temperature. It not depends upon any other parameters. Okay, as I said, du equals to Cv into dt means it is a function of temperature only. That we are going to prove here. Okay, just concentrate on these steps. We know that, okay, according to the first law of thermodynamics, Q equals to delta U plus W. Okay, whenever you are going to write in differential form, dq equals to du plus W. Okay, dq is nothing but what? TdS, because in entropy chapter we studied ds equals to dq by t. So dq is nothing but T into ds. You see, dq equals to du plus dw. It is a differential form of first law of thermodynamics. Then dq is nothing but T into ds. We studied in entropy chapter because ds equals to dq by t. So dq is the product of temperature and change in entropy. And du you put as it is, and dw, that is the displacement work done, is given by P into dV, as we derived this equation in module 1 only, that is in work done. So first you have to write the differential form of first law of thermodynamics. dq equals to du plus dw. Then the replace the term dq by t into ds. du as it is plus dw is nothing but t into dv. So first step you have to write differential form of first law of thermodynamics. Then you have to replace the term. Okay, and the next step, we are going to divide throughout by t. Okay, tds equals to du plus pdv. Next, we are going to divide throughout by t. What will get? Tds divided by t is nothing but ds only. And second term du by t plus p into dv by t. Okay, where ds is change in entropy, du is internal energy, t is temperature of the system, p is pressure, and dv is the change in volume. Okay, so this is the, you call it as equation number 1. Okay. Just you are going to divide throughout by t. Okay, and one more thing you have to write, as internal energy U is a function of only temperature and volume. Okay, so it is according to two property rule. Okay, any property is fixed by two independent variables. Here the internal energy studied the two property rule in pure substance. Same thing we are going to apply. Okay, any property we are going to specify by two independent properties. Like that, internal energy is a function of temperature and volume. So U equals to F of T and P. Now we are going to rewrite in differential form. Okay, differential form. Okay, du equals to del U divided by del T function of V into dt. So whenever you are going to write in partial differential format, we are going to write like this. Okay, so du equals to du by dt. First you are going to take the first variable, keeping v is constant, into dt plus du by dv into dv whenever keeping the temperature constant. Okay, like that. Hope you studied partial derivatives in mathematics. Okay, same principle we are applying here. So this is the equation you have to write properly. Okay. Du equals to, first you have to take del u divided by del v into dt plus second you have to take second variable del u divided by del v into dv, keeping the temperature constant, because the internal energy is function of temperature and the volume only. Okay, so next step, we got dv as this one. Okay, del u divided by del t into dt plus del u divided by del v into dv. Now substitute the value of du in equation number 1. Okay, so we are having equation 1 as ds equals to du by t plus p dv divided by t. We are going to substitute the value of du in equation number 1. Okay, so ds ls lhs you write as it is into 1 by t, and du is, you have to replace the term du by this term del u by del t into dt, 1 by t into del u by del v into t dv plus p by t into dv as it is. Okay, so du by t is, no, this is 1 by t is common for this entire du. That's why you have to write separately. That is 1 by t into this term, 1 by t into second term, and third term is p by t into dv. Okay, so here you are substituting the value of du in equation number 1. Okay. Next step, here you see first term we are having dt, second term we are having dv, and third term we are having dv. Okay, now I am taking the second and third terms and taking dv as a common term. Okay, so first term I am writing as it is, ds equals to 1 by t del u divided by del t into dt, and in second and third term I am taking dv as the common. Okay, so 1 by t, what will get? Del u divided by del v plus p. You have to take p inside, and dv is the common term in second and third terms. Okay, so just you write first term as it is, second and third term you put 1 by t as it is, del u divided by del v t plus p, you have to take the p inside the bracket into dv. You call it as equation number 2. Okay, to remember that, so that u is internal energy, it depends upon the temperature only. So like that, so first law of thermodynamics gives a new concept called as internal energy. Like that, the second law of thermodynamics gives a new concept called as entropy. Once again, the entropy is function of temperature and volume only. Okay, both internal energy and entropy both are functions of temperature and volume only, according to the two property rule. Okay, so remember U equals to F of dV like that. Yes, entropy is also a function of temperature and volume. Okay, how you are writing the differential form? Like that, same thing you are going to write for entropy also. Okay, so before that, first you have to write which is the function. S is a function of T and V. Then you have to write the differential form of this function. So ds equals to like that del s divided by del t. First you take the first term into dt, keeping v as constant. Next you have to take the del s divided by del v into dv, keeping the temperature as constant. Okay, you should be very careful in writing this equation, that is partial derivative equation. So ds equals to del s divided by del t. First term you take into dt plus del s divided by del v into dv, keeping the t as constant. How you are writing the internal energy? Same thing you are going to write for the entropy also. Next, you call it as equation number 3. Okay, now I'm going to compare the equation number 2 and 3, because left hand side we are having ds and I'm going to equate the RHS side equations. Okay, so comparing equation number 2 and 3, ds is same on both sides. So I'm equating the equation number RHS terms of equation number 2 and equation number 3. Okay. So from equation you see here dt is there. Here also dt is there. Okay. Now this term equals to this. Okay. And here dv is there. Okay. Here also dv is there. So this term is equals to this term. Like that you have to equate. dt, whatever you are having dt here also, you have to equate this term with this term. And here dv, here also dv, we have to equate this term with this term. Okay. Now you have to compare, that is del s divided by del t, okay, into dt. Okay, anyhow dt gets cancelled on both sides, that is exactly equals to 1 by t into del u by del t. So whenever keeping the volume as constant, del s divided by del t equals to 1 by t del u. Okay, dt and dt gets cancelled, that's why I don't consider that term. Now you compare the second terms of RHS side, that is del s divided by del v equals to 1 by t del u by del v plus. So you have to equate. So first step is you have to write u equals to f of t. Next you have to write the differential form. Next you have to write s equals to f of t comma v. You have to write the differential form. Then you have to equate this one. Okay. So you call it as equation number 5, 4, and this as equation number 5. Okay. Now we are going to differentiate equation number 4 with respect to V and keeping temperature as constant. Okay, you see the fourth equation, going to differentiate this equation with respect to volume and keeping the temperature as constant. And then after that, we are going to differentiate with respect to T and keeping V as constant. Okay, we are having only two parameters. One is with respect to V and another one is with respect to T. Differentiating equation number 4 with respect to V and keeping temperature as constant. So del square S divided by delta T into delta V, because it's a differential. equation with respect to v equals to 1 by t as it is del square u divided by del t into del v. So you call it as equation number 6. Just you put del v and del v on both sides of the equation, and this becomes del square u whenever you are going to differentiate. That is del square s divided by del t into del v equals to 1 by t del u square divided by del t into del v. You call it as equation number 6. Are you following, students? Any doubts in this one? Any doubts? Okay, next we are going to differentiate equation number 5. Okay, first write equation number 4 and 5. Differentiate equation number 4 with respect to v and keeping t as constant. Next, differentiate equation number 5 with respect to t and keeping v as constant. Okay, so this is del square s divided by del v del t equals to, so this one differentiating equation number 5, this one with respect to t and keeping v as constant. 1 by t del square u divided by del v del t plus 1 by t, that is okay, del p divided by del t because p is there, minus 1 by t square into del u by del v minus of p by t square. So this is the differentiation of equation number 5 with respect to v and keeping the temperature as constant, because we are having the two terms. So you are getting first this one and this one. Next you will get four terms. This del square s divided by del v equals to 1 by t into del square u divided by del v del t plus 1 by t. So differentiation of del p divided by del t, then minus of 1 by t square into del u by del v t minus of p by t square. So this is a differential equation. Whenever you are differentiating equation number 5 with respect to t and keeping v as constant, okay, call it as equation number 7. Now you see, comparing equation number 6 and 7, so the LHS terms are same. Comparing equation number 6 and 7, LHS terms are same. That is del square s divided by del v del t equals to. Now, once again, how you equated in the previous case, same thing. We are going to equate the RHS term, okay? Because LHS are same. Now, equating equation number 6 and 7, just you equate only the RHS term, okay? That is 1 by t del square u divided by del t del v equals to, and you have to write this term, that is 1 by t del square u divided by del v del t plus 1 by t del p divided by del t minus of 1 by t square into del u divided by del v minus of p by t square. Okay, so you are going to do two times differentiation. Okay, next you see, compare this equation, this term and this term gets cancelled because the same content, and remaining term you can rewrite like this. Okay, del u divided by del v. Okay, now so after cancelling this term, what I are going to do is multiply throughout by t square. So they are not written here. You have to multiply throughout this equation by t square. Okay, and rearrange the terms. Okay, I am taking these two terms one side, that is at LHS side. I am shifting these two terms LHS side and keeping the RHS term as it is. Multiplying throughout by t square means t square divided by t is nothing but t into del p divided by del t as it is, and you have to shift towards left hand side, multiply by t square, because t square and t square gets cancelled, you'll get only one term, that is del u by del v and plus p by t square into t square is nothing but you'll get only p. Okay, so here you are going to do multiply throughout by t square and rearranging the term and keeping this term in the right hand side itself and shifting these two terms towards left hand side. So del u divided by del v plus p, because t square gets cancelled, and whenever you shift towards left hand side it becomes plus. So del u divided by del v plus p equals to t into, because t square by t is t, into del p by del t. So till now we'll learn this one. Next, according to the ideal gas equation, we have PV equals to RT. We derived this equation in the previous class. This is the ideal gas equation. PV equals to RT. Now, once again, you have to differentiate. As I said, so we are considering only the functions of temperature and volume. Just you differentiate with respect to P only. Okay, the variable parameter is P only, and remaining all are constant, because we are considering that the entropy, the internal energy is a function of temperature and volume, hence keeping the volume and temperature constant and differentiate only with respect to P. Okay, so here P del P by del T, okay, equals to R, del T by del T is nothing but 1. To rewrite V into del P by del T, keeping V as constant, equals to R. Okay, that is del T by del T is 1. Okay. Next, del P by del T. You remember, very simple differentiation. First, you write the ideal gas equation and differentiate only with respect to uh, T for the parameters P and T. So V into del P by del T, V star into del T by del T is 1. So don't write R. Now del P by del T equals to R divided by V. That is, R by V is nothing but what? P by T. Because PV equals to RT. So R, you see, here it is R, and keep taking the V as the denominator. R divided by V is nothing but P by T. How you get this one is PV equals to RT. So R by V equals to P by T. Okay. Now substitute the value of del P by del T as P by T in above equation. As you see, do you call it as equation number 8? Okay, it's not mentioned here. And del P by del T is nothing but P by T. Substitute the value of del P by del T as P by T in this equation. And you rewrite this equation, don't change this term, that is del U divided by del V plus P as it is, T as it is, into del P by del T is nothing but P by T. So this T gets cancelled, PP gets cancelled, del U by del V equals to 0. Okay. Now, similarly, so whenever you put the pressure, del U by del V equals to 0. Okay. So because U equals to, now after integrating, so you can rewrite it as U is function of temperature only. Del U by del V is 0. Similarly, del U by del P is also 0. So integration of this one with respect to T is constant. So integration of 0 is constant. So we can finally conclude that U equals to F of T, because this term is 0 with respect to V is also 0, with respect to P is also 0, and remaining parameter is only the temperature. Okay, hence we can say that U, after integrating, you get integration of d equals to integration of 0. Integration of 0 is nothing but constant. Here you see keeping temperature as parameter. Hence u equals to f of t only. Okay, it is a function of temperature only. And this law is called as the Joule's law. You remember, it is called as Joule's law, and it is function of temperature only. So this is one of the important derivation what I taught today. Every time they used to ask this derivation in the exam, you have to concentrate properly. This internal energy is a function of temperature. Next, enthalpy is also a function of temperature only. So based upon this one, we can prove. It is very simple. So enthalpy is H equals to U plus PV. We know that H equals to U plus PV. This is a standard formula for enthalpy. H equals to U plus RT. PV is nothing but RT. Just you replace the term PV equals to RT. So just now we proved that internal energy is a function of temperature only. Hence, the enthalpy is also function of temperature only because we're having the internal energy term in enthalpy. As the enthalpy is function of temperature only, hence we can say that the enthalpy is also the function of temperature only. H equals to U plus RT because U is function of temperature only. And you remember whatever the equation we studied in module 2 and 3, same thing we are going to study. Next, so already you have done this process. Okay. Now same process you are studying. Okay. I'll repeat once again. This is a constant volume process. Okay. So here you should remember the expression for work done. What is the expression for internal energy? What is the expression for enthalpy? What is the expression for change in entropy? Because it is a combination of all chapter. Hence, same formula, whatever used in the previous chapters, you are going to use the same formula. Okay, only that's why it is a summation of all the chapters. The first, just for recall, I'll repeat once again. The constant volume process, PV diagram is like this, okay, and TS diagram is like this. That's why you practice PV and TS diagram. So it is the nature of curve, okay. At state point 1, P1 V1 equals to MRT1. At state point 2, P2 V2 equals to MRT2. Okay, right? This equation, and V1 equals to V2. So whenever you take the ratio, you get P1 by P2 equals to T1 by T2. So P1 by T2 equals to T1 by T2 equals to constant. And in the exam, they will give three conditions, and remaining fourth condition you have to find out using this equation. Okay, P1 by P2 equals to T1 by T2 whenever the volume is kept constant. Okay. Next, already we derived the expression for our heat transfer. Q equals to du plus integration of PdV. Okay. So this is the expression for heat done, and du is U2 minus U1 plus work done during constant volume process is 0. Okay. So the amount of heat transfer and change in internal energy are same. And you remember delta U is always given by mCV into delta T. This is the expression for the heat transfer. Q equals to delta U plus integration of PdV. Work done is 0. So Q equals to mCV into delta T. So work done is 0. And the change in internal energy. So these are the five things you should remember. One is the heat transfer. Second one is work done. Third one, change in internal energy. Fourth one is change in enthalpy and change in entropy. So they will ask the question based upon this formula only. That's why I try to understand the process. Remember the formula and you have to use the formula accordingly. The change in internal energy, it is mCV into delta T. This is a standard formula for all the process. And change in enthalpy, and this is also standard formula, mCp into delta T. So whatever process it is there, you remember these two are the standard formula. And the change in entropy is already we derived. Integration of ds equals to s2 minus s1, and dq by t. Integration of ds is dq by t. What is dq is nothing but cv into delta t. So what we studied here, cv into delta t divided by t. So after integrating, we get ds is change in entropy Cv ln at T2 by T1. So you have to remember this formula also for change in entropy during constant volume process. Next, constant pressure process. Okay. So first you have to write the PV diagram. Next, TS diagram. PV diagram between 1 to 2. Write the state points. P1 V1 equals to MRT1. P2 V2 equals to MRT2. So P1 equals to P2. So We can take the ratio P1 V1 divided by T1 equals to P2 V2 divided by T2. P1 and P2 gets cancelled. So we can write P1 by T1 equals to V2 by T2. So already studied Boyle's law and Charles law. Same thing here also. V1 by T1 equals to V2 by T2. Next, heat transfer, you have to write the first law of thermodynamics, differential form of first law of thermodynamics. That is dq equals to du plus pdv. So q equals to delta u, that is nothing but u2 minus u1 plus integration of pdv. Work done is always given by integration of pdv. We know that the h equals to u plus pv. And differential form is dh equals to du plus pdv plus vdp. So differential form, first you write du plus p into dv plus v into dp. Okay. So this is the differential form of dh, and then dh write as it is, du as it is, and at constant pressure p into dp is 0. Okay, at constant pressure process. So dp, the term dp is 0. So neglect this term. dh equals to du plus pdv. So du equals to, you shift this term. It's very simple. Try to understand. Just you are going to differentiate the equation. H equals to u plus pv. dh equals to du plus pdv plus vdp. dh equals to du plus pdv because vdp is 0. At constant pressure process, this is 0. And then du dh minus pdv. Just you shift this pdv towards left hand side. Okay, what you'll get? Du equals to dh minus pdv. But we know that dq equals to du plus pdv. How we get means q equals to delta u plus w is nothing but dq equals to du plus pdv. Now, but du is given by dh minus pdv. So substitute the value of du as dh minus pdv in this equation. So dq equals to du plus pdv. We got du as dh minus pdv. We have to substitute the value of du as dh minus pdv in this equation. dh minus pdv plus pdv minus pdv gets cancelled plus pdv gets cancelled. So you'll get dq equals to dh. Whatever the amount of heat transfer is exactly equals to the enthalpy in case of the constant pressure process. Simple derivation. And work done is given by integration of pdv. Already studied p into v2 minus v1 or p to v2 minus p1 v1. And internal energy, I said you have to remember the standard formula mcv into delta t, because we considered the constant volume. Standard formula is mcv into delta t. This is the Joule's law. Just now we studied. The internal energy is a function of temperature only. It does not depend upon any other parameter. And standard formula for internal energy is given by mcv into delta t. Similarly, enthalpy is mcp into delta t. These formula don't change. These are the common formula for all the process, whatever it is. But don't confusion that here it is cv, we are having constant pressure process. It is not like that. It is a standard formula for all the process. And entropy is given by integration of ds equals to s2 minus s1. That is integration of dq by t. So cp into integration of dt by t. Okay, so it is cp into log a t2 by t1. And in case of constant volume process, we are having cv. There is a difference. Here you see cv into log a t2 by t1. Here we are having cp into log e t2 by t1. Okay, that's why first you understand the nature of curve, then you do the derivation. Okay, constant temperature process. Okay, this is the nature of curve, parabolic law, that is PV equals to RT, and this is the nature of curve in case of TS diagram. Because temperature remains same. So this is the one is PV diagram and one is the TS diagram. Next, you have to write for the state points P1 V1 equals to MRT1, P2 V2 equals to MRT2. Because M is constant, R is constant, T is also constant. So we can write P1 V1 equals to P2 equals to constant for isothermal process. See, M is constant, R is constant, T is also constant for isothermal. So P1 V1 equals to P2 V2 equals to constant. So the heat transfer is given by, you write down Q equals to W plus delta U. So delta U is 0. Can you tell me how we get delta U is 0 here? Anybody? Anyone? How will get delta U is 0 in case of isothermal process? Anyone? Q equals to W plus delta U. Delta U is 0 for isothermal process. How? So because as I said, delta U is MCV into delta T. Okay, MCV into T2 minus T1. In case of isothermal process, it is T1 and T2 are same. So delta U is 0. So Q equals to W. Already we derived this expression P1 V1 log E V2 by V1. Work done is given by integration of PdV. Already we derived this expression. You get P1 V1 ln V2 by V1 RT1 into ln V1 by P2. And the internal energy is given by, as I said, internal energy is 0 in case of isothermal process. And enthalpy is also 0 because dt, T2 minus T1 is 0. And entropy is given by integration of dq by t. Dq is RT1 ln P1 by P2 divided by T. Okay, so T gets cancelled, you get R ln P1 by P2. And reversible adiabatic process. Okay. Anyhow, Q is 0. This is the nature of curve. Q is 0 for adiabatic process. And work done already we derived this expression. You'll get P1 V1 minus P2 V2 divided by gamma minus 1 or MR T1 minus T2 divided by gamma minus 1. So next internal energy is MCV into delta T, you remember as it is, and MCP delta T for enthalpy, and entropy change is 0 because delta S is dq by t. dq is 0. Hence, there is no change in entropy during the adiabatic process. And finally, we studied polytropic process. Polytropic process, the nature of curve is same. PV and TS same. Okay, and we derived the expression for work done also. That is W equals to P1 V1 minus P2 V2 divided by N minus 1. And you remember the heat transfer formula MCV into delta T. And this one more formula I derived, that is Q equals to gamma minus 1 divided by gamma minus 1 into polytropic work done. Okay. So the heat transfer during the polytropic process. Work done we derived, that is P1 V1 minus P2 V2 divided by N minus 1. In terms of MR T1 minus T2 divided by N minus 1. And change in internal energy, you should remember the standard formula. This is same for all the process. Delta U is CV into delta T and delta H is CP into delta T. And this one, these are the entropy formula we studied. I derived in terms of T and P, T and V, and P and V. Just go through that derivation. That's whatever the derivation you had done in the previous chapter, same equation you are using for the problems in this chapter also. Hence, understanding of all concept is important. Once those who have not entered USN, please enter USN in the chat box. Okay. Any doubts in this concept? Okay. Once again, go through that derivation, whatever I taught today. That is, internal energy is a function of temperature only. And you take sheets of paper, there you write all the 5 process, PV diagram and TS diagram, and you write the equation for all the things like what is change in internal energy, what is work done, what is heat transfer, what is change in enthalpy for all the process. You make a chart, you write all the equation. It is very easy to remember for the test as well as for your final exam. I'll stop the session now.